In this tutorial, the method of scattering implementation of any objects on the floor using a Yeti model will be discussed. At first glance, mud, snow, twigs and other small items may cause some difficulties in the implementation of the project. I'm sharing a recipe that I often use in my practice. As an example, I will use one of my works, a baby cheetah. As an object, I choose snow. I will scatter it on the main. Let's start! First, we need to prepare objects for scattering. These are the basic requirements for objects. They should be all located at the origin of coordinates so as they pivot. The normals must be pointed outside. There are no requirements for the number of polygons as well as the topology itself. You may use objects with holes and not welded vertices. The principle itself remains a particle instance in Maya. Next, we need to choose a layer of fur on which we want to scatter the snow. In my project, the main consists of 3 layers. I will be scattering objects on the main layer. For convenience and speed, I will disable the display of fur in the viewport. We add our objects in the Yeti node and import them into a tree. I'm going to add a transport node. It allows us to change the scale of each individual instance of an object when needed. We copy these 2 nodes and specify in each node the object that you want to import. Next, we connect them using a merge nodes. So far, nothing complicated, but it will get more interesting. We use 2 important nodes: group node and instance node. Group node is used to limit the instance node. We need it if we want to scatter our objects throughout the floor depending on the specified percentage of the total numbers of hairs. To do this, we switch group node to expression mode. Next, we write a simple expression, which gives us the remainder of the division using the operator %. ID is the number of hairs. The result of this expression is the numbers of fibers on which snowflakes will be located. In this case, it's about 5%. Specify the name of the group. We input the same name to the specific field in the instance node. Next, in the Object tab, we will switch the sort of objects from the first to the cycle. Now, we see how all 3 of our objects are processed. Let's see how it will look with the fur. So far, so good, but all of our objects had 4 roots. Now, let's try to move them to another place along the hairs. It's a peasy lemon squeezy, but let's give our fur a tint so that we could visually distinguish instances from objects. And now, let's go! There is a wonderful tab called Selection in the instance node that allows us to manage the selection of the landing point of objects. We will indicate this in the element point index line now. Currently, there is 0. It is just 0 point in the single hair. Now, we need to find and indicate, for example, the highest point. This info we can easily find out in the Grow node in the Geometry tab. You can see that there are 40 segments in the segment count line. Let's replace 0 to 40 in the element point index. And if we done all correctly, we will see our objects on top of the 4 hairs. Cool! Now let's complicate the task and, for example, arrange the objects randomly along the hairs to make it look more natural. It sounds difficult, but actually it is not. Yeti has global variables for an instance node, and we will use one of them. How to find out about them, or how to find out about any variables and statistics in general? Right-click on the node and voila! We can see everything about it. For an instance node, we need a variable that transmits the number of points on the single hair, and this variable is a vertex count. We write the expression for random search using the cycle function. It should be 3 values. First is a variable by which enumeration will be performed, and in this case it's ID. Second and third is a minimum and maximum search values. In our example, we will iterate from the base to the vertex count, and we remember that we now have it equal to 40. In our example, we will go through from the base to the vertex count, and we remember that its value is 40. Now, if we change in the Grow node number of segments, the instance node will automatically iterate to the maximum value of segments. Let's increase the minimum value to 10. Still working. And up to 30. And we see that the objects are located in a narrow area on the ends. Let's lower the value of objects to 1% for speed, and add the user variables, and then make a small animation. Here I added 3 variables, 1 for the scale and 2 for the minimum and maximum values in the expression. And here's our result. Grooming. Now, let's look at the option of placing objects using strands. To do this, we add the user attribute in the Groom node and reset its value to 0. Next, we need to add it to the Yeti node using the attribute node. Then, we use this attribute as a multiplier in the scale attribute. And that's all. Then we have to paint the values from 0 to 1 with a brush. Also, In the same way, we can use any noise function. Rendering. How can we now render both fur and objects? To do this, we will also use custom attributes in Yeti. We create the attribute node, give the name of the attribute, and specify the value 1 for the objects. Duplicate this node for fur, and put the node for the objects before the instance node. The duplicated node is placed at the very end of the branch, which is responsible for all 4, and we change the value to 0. Next, in the instance node on the object tab, in the inherit attributes line, we specify our attribute to pass the attribute further on the branch. That's all we need to do in Yeti. We need only to make a few movements for Arnold. That will be similar for V-Ray and for other renders. To do this, we need to create eye switch shader that allows the switching for other shaders depending on the index. In the shader with index 0, we use the shader for fur, and for 1, the shader for objects. In the index attribute, we feed the iUser data float, in which we specify the name of the custom attribute specified in the Yeti. As you can see, everything works correctly. UVs of objects also work and are transferred for the render. That's all. I hope you enjoyed this tutorial and it will be useful for you. Bye!